In this video, I will show you how to graph an ellipse that is centered at the origin. Along the way, we will identify the vertices, the co-vertices, and the foci of the ellipse. Here are the notes giving you the details on the standard equation of an ellipse that is centered at the origin, 0, 0. And so these are the main two equations that you need to pay attention to. Now notice the vertices A, B, and C and what they represent. So when you have an ellipse, you have the long way across and you have the short way across. If you go the long way across, those ends are called the vertices. All right, the vertices always are the long way. When you go the short way across, the sides, if you will be the co-vertices. Now these points that are inside the ellipse going the long way like this are called the foci. Okay, and as you can see, the vertices will be given by the variable a, positive and negative. The co-vertices, the short way, that's b, and the foci, that's c. Now the way we're defining it, a is always going to be bigger than b, or at least the absolute value of a, or a squared will always be bigger than b squared. All right, because a is always the long way and b is always the short way. A squared minus b squared equals c squared. This is a formula that you need to memorize relating these three variables. All right, there's also one additional thing, eccentricity. We'll talk about that more in future lessons, but just memorize that the eccentricity is always c over a. It's a number that reflects how far away you are from being a circle. All right, one more thing. Sometimes an ellipse is stretched out horizontally, and sometimes it is stretched vertically. So the equation will change a little bit. You will know that it's going to be a horizontal ellipse if the bigger number is with the x. And you'll know that it is a vertical ellipse if the bigger number is with the y. So as we begin to look at equations and graphs, in your mind, the first thing you should do is ask yourself, is this going to be a horizontal ellipse or is it going to be a vertical ellipse? So looking at problem number 1, we notice that the bigger number is with the y value. So you know this is going to be a vertical ellipse in the way it's stretched. Okay. By contrast, when we get to number 2, see how the bigger numbers with the x, that lets you know that this would be a horizontally stretched ellipse. Getting back to problem number 1, remember that the a value is always going to be the bigger number, and the b value is always going to be smaller. So that tells us that the 36 is a squared, and the 16 must be b squared. All right, so that means, of course, that a is 6 and b is 4. So a is 6 and b is 4. Okay, we also know that c squared is equal to a squared minus b squared. So that means we can quickly calculate what c is. So c squared will equal the 36 minus 16. Which means, of course, that c squared is equal to 20. Taking the square root of both sides, c is equal to the square root of 20. Since 20 is 4 times 5, that means c is 2 radical 5. Okay, so 2 radical 5. So we have our a, b, and c. Of course, the center is going to be 0, 0. We know that because the equation just involves x squared and y squared. It's not, for example, x minus 3 squared over 16, or y plus 5 squared over 36. All right, if it's just x squared and y squared, that means you're talking about 0, 0 as the center. While we're doing letters, let's go ahead and take care of E, the eccentricity. Remember that E is C over A. Just memorize that. So that means E is going to be 2 radical 5 over 6. So that's going to reduce down to radical 5 over 3. All right, so let's start graphing and talk about the vertices and co-vertices. The vertices are going to go along with the A value. To do this right, we have to keep in mind at every step whether or not this is a horizontally stretched ellipse or a vertically stretched ellipse. And again, because the bigger number is with the y, this is going to be a vertically stretched ellipse. So when I do this A value of 6, that means I'm going 6 in the y direction. So if I go up 6 from the center, which is 0, 0, all right, that's going to be a vertex. And if I go down 6, that's going to be a vertex. Okay, so right there, the vertices are going to be 0, 6 and 0, -6. Similarly, the co-vertices are always going to be associated with the B value because the smaller number is with the X. We know this B value will be in the horizontal direction. So the B value of 4 tells me that I will go left 4 and right 4 from the origin. Okay, so these will be my co-vertices, which are -4, 0 and 4, 0. Based on the vertices and the co-vertices, we can see that the ellipse will be right here. So the last thing we need to do is go ahead and figure out what the foci are and graph them. So the foci will be associated with the C value. For the purposes of graphing, it would be helpful to know the approximate decimal value of this. All right, so 2 radical 5 turns out to be approximately 4.47. I'll just say approximately 4.5. Okay, so that helps us know where to graph it. However, when I say the when I say the foci, I will use the exact form involving the 2 radical 5. I won't say 4.5 when I list them here. So the foci are always going to go the long way. They're always going to go on the major axis. Okay, so I think I'll just switch colors over to green here. So 4.5 would be here, and then I will have -4.5 here. All right, so that helps me to visualize that the coordinates of this point are 0, and I'm going to switch back to that 2 radical 5. And this one is going to be 0, -2 radical 5. So these are the foci. And that is how you graph an ellipse. Let's try number 2. Again, the A value is always going to be the bigger value. So I know that this is A squared right here, which means that A is 7. The smaller value is going to be the B squared. So that means that B is 2. So let's write that down. So A is 7 and B is 2. Now, is this going to be horizontally stretched or vertically stretched? Because the bigger number is with the x squared term, that tells me that this will be longer in the x direction. All right, so when I go to do my vertices later, that means I'm going to take the 7 and I'm going to add and subtract horizontally. So I'm going to go 7 to the right, okay, and so I've got 7 comma 0, and I'm going to go 7 to the left. That's negative 7 comma 0, and those will be my vertices. Okay, negative 7 comma 0 and 7 comma 0. All right, my B value, the short way, will be in the y direction. So looking at my B value of 2, I'm going to go up 2 and I'm going to go down 2. These will be my co-vertices. So this is 0 comma 2 and this is 0 comma negative 2. Okay, so those are my co-vertices. Okay, now of course the center is still 0 comma 0, and I know this because it's simply x squared and y squared, not like x minus 3 squared or something like that. All right, what else do we need? We need the c value and the e value before we get too carried away. The c value, let me change colors for a quick second. C squared is equal to a squared minus b squared for an ellipse. So c squared is going to equal the 49 minus 4. So that means that c squared is going to equal 45. So that means that c is going to equal the square root of 45. Whoops. All right, and considering that 45 is 9 times 5, that means that c is 3 radical 5. Now let's talk about e. All right, e is for eccentricity, and e is always equal to c over a. So that means 3 radical 5 over 7. And that's it. Doesn't even reduce. So e is equal to 3 radical 5 over 7. C over a. Okay, what else do we need? We need the foci. The foci will always be associated with the c value. And let's go ahead and draw the ellipse real quick, though. Based on the vertices and the co-vertices, we can already see what's happening with the ellipse. All right, it's doing this type thing right here. Okay, that is what our ellipse is going to look like. So the foci are always going to be on the major axis. Okay, they're always going to be the long way. So it would be helpful to know a decimal approximation for this c value here. So 3 radical 5 is approximately 6.7. So I will go 6.7 along the major axis. So if I go 6.7 to the right, well, 6.7 is really close to the vertex over there. Okay, and it's going to be negative 6.7. It's going to be really close to the vertex over here. But when I label these, I will go ahead and use the square root version of this. So this will be negative 3 radical 5 comma 0, And this will be positive 3 radical 5, comma 0. Okay, and that's it. Again, that is how you graph an ellipse. All right, let's take a look at number 3. We need to do a little bit of algebraic manipulation before we can really get started. So let's look back at our notes for a second. So notice in both versions of the equation for an ellipse, we have 1 on one side. The whole thing is equal to 1. Okay? Either way you look at it. So this needs to be a 1. All right? Right here we see the 16. So we are definitely going to have to divide by 16. And for that to be a legal algebraic move, we need to divide both sides of the equation by 16. So what's that going to give us? All right, so this is going to give us x squared, and I'm going to purposefully go ahead and put over 1, even though normally we wouldn't put a 1, but just to make it look as much like this as possible. Okay, and then we have this plus y squared over 16, and that is equal to 1. So this is what we will look at for the rest of the problem. Remember, the bigger number is a squared. So this is a squared, which means that a is equal to 4. This, the smaller number, is b squared, which means that b is equal to 1. Okay, so a is equal to 4, and b is equal to 1. Okay, now the bigger number tells us whether the ellipse will be stretched horizontally or vertically. Because the bigger number is with the y squared term, that tells us that this ellipse will be stretched out vertically. So the major axis will be vertical. So to place the vertices, I am going to go 4 above and below the center. So I'm going to go 4 up, and I'm going to go 4 down. And these will be the vertices. Okay, so this will be 0, comma 4, and 0, comma negative 4. All right, those are my vertices. By the way, the center again is 0, comma 0, because it's just x squared and y squared. Okay, the co-vertices are going to come from the b value. All right, because the b value is with the x squared term, we know that we will be going horizontally with the b value. So I'm going to be going 1 to the left and right. So the co-vertices will be negative 1, comma 0, and 1, comma 0. All right, that's actually enough for us to be able to draw the ellipse for ourselves. Okay, so the ellipse should be looking something, whoops, too far, something like this. Okay, but let's find the rest of these letters that we need. We need the c value still. Okay, for an ellipse, we know that c squared is equal to a squared minus b squared. So c squared is going to equal 16, all right, because that's a squared, minus 1. So c squared is going to equal 15. So c is equal to the square root of 15. All right, we also need the E, the eccentricity. And E is always C over A. So that's just going to be the square root of 15 over 4. So that's the eccentricity. Finally, we need the foci. For that, it would be helpful to know the decimal approximation of the square root of 15. All right, that's approximately 3.9. That's going to put it really, really close to the vertices. But anyway, we got to deal with that. So the C value gives us the foci, which always go the long way. So I need to go 3.9. So look, I'm just going to put this as close as I can to the edge without touching. All right, but understand that that's approximately 3.9 in both directions. Okay, now when I label this, I'm going to use radical 15 though. So 0 comma radical 15 and 0 comma negative radical 15. And that's it. That is how you graph an ellipse and find all the stuff. Let's take a look at number 4. Again, when we look at the equations for the standard form of an ellipse, we always have equals 1 right here. So here I have a 36. So I definitely need to divide by 36. On both sides. Now I'm going to just reduce. 9 over 36 is 1/4. Right? So that's why this is going to be x squared over 4. I'm just reducing. Similarly, I will have y squared over 9. 4 over 36 is 1/9. I'm just reducing. And 36 over 36 is 1. The a value is always going to be the bigger number. So this must be a squared, which means that a is equal to 3. This is going to be b squared because it's the smaller number. That means b is equal to 2. Let's write that down. So a is 3 and b is 2. Okay, now because the bigger number is with the y squared, that tells me that this will be a vertical ellipse. It will be stretched in the y direction. So when I take my a value of 3, I'm going to add and subtract in the y direction. I'm going to go up 3 and down 3. Like that. Okay, so that's going to give me my vertices. So one vertex is 0, 3, and another vertex is 0, negative 3. Okay, of course the center is still 0, 0, because I still just have x squared and y squared. I don't have like x minus 5 squared or anything like that. Okay, what about those co-vertices? The co-vertices are associated with the b value. The b value is with the x squared term, so when I do the 2, I'm going to go in the x direction. I'm going to go right 2 and left 2. All right, these are my co-vertices, negative 2, 0, and 2, 0. Okay, that's enough information for us to be able to graph the ellipse. So let's go ahead and do that. Boom. Okay, so now we've graphed the ellipse. Now let's fill in these last two letters and find the foci. Let's start with that C value. Okay, if I want to find the C value, I'm going to keep in mind that C squared is equal to A squared minus B squared for ellipses. So C squared is going to equal the 9 minus 4. So C squared is equal to 5. So C is equal to the square root of 5. All right, later it will be helpful to know the decimal approximation for this. So I'm just grabbing a calculator real quick. The square root of 5 is approximately 2.2. So keep that in mind. Okay, while we're at it, let's go ahead and do the E value. The eccentricity is the C value over the A value. So that's going to be the square root of 5 over 3. There's my eccentricity. Now, let's use the C value to find the foci. All right, the foci always go the long way. They will always be sitting right on the major axis. And so since I know that the decimal approximation is 2.2, then I will go 2.2 the long way. So 2.2 is about right here, and I will go negative 2.2 is about right here. Now when I label these points, though, I will use the square root form. So this is 0 comma radical 5 and 0 comma negative radical 5. And that's it. That is how you graph an ellipse and stuff. All right, that's it for number 4. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.